Hi. Hi. Ahora. Ya estás. Lo único. Mute. Vale. Esto fuera. Fuera. Y esto lo tuyo. Esta también bájala. ¿Ya está? ¿Ya está?
Okay. Okay. So first I'm going to talk a little bit about the history of Blender, some minutes. Blender is based on, well, the Blender Foundation, that's a foundation of people that develops the software itself, and not only the software, but some other projects around it that I'm going to talk about later, is based on Amsterdam in Holland. Blender is a software that started as an in-house solution for a movie producing company that I don't remember the name. And they stopped developing it, but the community around it, some people around it, gathered some money and make like a crowdfunding. In those times, there wasn't the concept of crowdfunding like a normal concept, but they did it. And they bought the rights over the initial piece of software, and they release it as an open source package. And after that, there are some crazy people around the world like me that get Blender and start working with it a long time ago. And a lot of people not only use Blender as a tool, but start developing inside Blender. Since it's open source, you can download the code, and if you have some knowledge about programming, you can start adding things. No? So the community started growing up very fast. And it started to develop Blender in different directions. Initially, it's a tool more fitted to 3D artists, no? To do 3D animation, 3D modeling, sculpting, stuff like that. But each part of the community has its own interests, so at the end, it's developing more like a star with several different branches. No? For the CAD purposes or let's say, or things around fabrication and stuff is the less developed part of Blender. But since it is a very powerful package, you can use it for that. In fact, today, it's not very big, but there's a fork. I imagine you know the concept of fork, and you already had GitHub and stuff like that. So there's a fork of Blender that's called Mechanical Blender, I think. They are developing Blender more for like a CAD package for managing robots, for developing G-code, etc. Okay? So there's a lot of things around it that make it very powerful for this kind of, for the kind of projects we can build in the Fab Academy, let's say, because you can also use Blender has a Python base of scripting engine inside, so you can interact with the real world with Python very easily. So it's very common to do projects like a little robot that you can control from inside Blender, you know? or some sensors where you can gather some information and put it inside a virtual world inside Blender. Okay? Blender has, for example, a game engine, like the Unreal Engine or stuff like that. It's not that big because it's not the center of the project, but you can do interactive games inside Blender, and you can connect them to external sensors, external inputs, let's say, no, with the Python scripting. Later on the course, we're going to have well, at least last year we did a class of Blender and the reality connecting together. No? So we can script a little bit of Python and connect some sensors and move your phone that moves some things inside, or move a resistor or a potentiometer or whatever. Okay? So this is the page. The fact that it's free software is not only that it's free in price, as in beer they say, it's also free as in freedom. No? You can use it for whatever you like. You don't have to pay anyone anything. You don't have to reserve any kind of license. And also you can do your own Blender if you like. You can customize it to whatever you like. So this open source project, this free project, is very successful inside the free software world because they have followed let's say, a development way that's very interesting to the community. They started not only putting some developers to work and develop a software, but also they involved the community, and they started building projects where they make invitations to the more, let's say, they make votes around the community. Who's the best artist in that city? So this guy won. They paid some money to the guy to go to Amsterdam 6 months and develop an open movie. They developed the concept of open movies. They made animations, shorts, animations. They are working also on a, I don't know how to say in English, a long movie, not just a full feature movie, exactly. And the good thing is they gather artists from the community and they put them together with the developers. So the artist is saying, I want to do this, how to do it? And the developer starts working on how to do a tool that can do that. So that model started growing a lot, and a lot of people start giving them money for them to do these projects. And right now they are developed around 6 or so movies. And that has given them a lot of money to develop and to grow the foundation and develop a really big software. When Blender began, it was like a really little brother of 3D Max, and I started doing animation a long time ago with 3D Studio 4, the previous software from 3D Max that later became 3D Max. And Blender started a little later, and it was like not a toy, but very difficult to use and not so big. And right now it is competing in big studios with 3D Max and Maya. And some of the companies are starting to use it as a primary tool. Not because it is open source, because they don't care about that, but because it is competent, in the work they do. So I'm going to show you more or less first the interface, the parts of Blender, what kind of things you can do with it, and then we go inside some of those parts. Well, Blender, as any 3D package that's designed more for artists, has a render engine, let's say, where you can render your models with lights, with cameras, with a lot of different things to make it look good. It is designed to do movies mostly, so the tools for getting good images out of Blender are very powerful. That has some advantages when you are developing projects, because you can present your projects very nicely from the same package where you develop the geometric stuff. Okay. Blender now has a render engine that's called Cycles, that's GPU based, and if you have a big computer with an NVIDIA or a Radeon big graphic card, you can render on real time at very good quality. Then Blender has a big part dedicated to modeling. That there's a lot of tools around modeling. One of the disadvantages of using Blender against, for example, FreeCAD in the case of open source software, or any CAD package like AutoCAD or whatever, is that it's based more on meshes. If you understand the concepts on how a 3D model is built, there are different ways of building a 3D model. One of those is based on meshes. Meshes have different components, vertex, edges, and faces, and they build a model based on those points. So you cannot, for example, build a cube, and after some time doing modifications on the cube, you can just, in some other packages, you can just change the size of the cube and the cube will scale. In this case, there is no concept as a cube. There are 8 points in space joined by several lines and several faces that do a cube. But you cannot just say scale the cube to this size, okay? That difference between parametric modeling and mesh modeling is important when you're doing mechanical stuff. But there's a lot of ways to go with that problem without needing the parametric stuff that, for example, AutoCAD does. And in mesh modeling, Blender is very powerful. So, for example, for 3D printing and 3D scanning, is very good because you can manage very well big meshes. When you do a 3D scan, normally you get a cloud of points, and then you have to build surface with it, and then you have to, let's say, correct the errors in those surface and stuff, and Blender is very good to doing that kind of stuff. Well, for VFX, there's a lot of tools inside Blender. Blender has, for example, a tracking, camera tracking module where you can input something that you get with the camera, and you can calculate the real position of the camera in the real world. So when you put a 3D model on top of that video, it will look like it is inside, okay? Because it will move like the camera point of view, when the camera point of view changes. There's also a compositing node-based interface where you can do a lot of 2D and also some 3D effects over videos. So you can render some part of your movie in Blender and compose on top of footage get by a camera and do green screen, for example. That's very common on these days. You can do a lot of stuff like that. In terms of VFX, there's also, we're going to see some of those later, some examples of that. A lot of simulation engines for physics, like liquids. You can simulate fire, you can simulate smoke, cloths, soft bodies, how the objects will behave if you put some gravity, different types of materials, etc. Well, then Blender is very powerful in terms of animation, because since it is developed for doing movies, of course you have to animate. So for doing animation, there's a lot of different things. For example, the rigging part. Rigging is like doing a skeleton for some model that will modify that model when you move the skeleton. So for character modeling and stuff, there's a lot of tools for doing that. I think those tools we are not going to use them that much here, but you can also rig robots and rig machines. The printer that you saw some minutes ago, I will show it to you later. I have it rigged in a way that when you move some axis, all the parts that are involved in that movement will move also, no? In the correct way. So you can rig also gears, you can rig whatever mechanical things you need to calculate how the movement will be. Blender also has like a 2D engine, let's say. You already seen Inkscape, I think?
Not yet.
Sorry?
We haven't really seen it yet.
No? Okay. You haven't worked with any 2D package yet? No? Okay. But not here in the class, I'm saying. Okay. So Blender has different tools for modeling, let's say, 2D curves, but also for painting. It's like it's called grease pencil. The idea for the guys that do cinema stuff is that before all of these tools existed, they have grease pencils and they draw on top of the screen. And then with the paper, they clean the grease and they start drawing again, so they can design more or less the scenes they are building. You know? So that tool is inside Blender, so you can draw in colors and stuff over a 3D scene. No? I'm going to start showing you some videos of what I'm saying, so you can get more the idea.
Yeah.
This is, I'm going to leave it down while I'm talking, so you can more or less check it here. For example, this is a drawing made by hand in Blender with all the, if you see the right part of the interface, there is layers like in Photoshop, for example, or Illustrator with colors. But the thing is, every 2D drawing gets some deep, and it's in a 3D space, okay? And you can animate it as it was an independent object. And you can do several drawings that are chained in time and also in in a 3D space, and you can move them and animate them inside the 3D space. No? So it's a strange concept at the beginning, but it's like having several screens with beep inside, and you also have the variable of time. Okay, this is cool because you can mix like sketchy stuff where you can start dropping your ideas on top of a real 3D model that you later are going to cut in CNC, for example. No? Well, we also have, let me go to here. Yeah, Blender is pretty cool, I agree. The last part of their page is make it your own. I already talked a little bit about this. You can do whatever you like with Blender, but not only in terms of programming and downloading the code and do it your own Blender, but the interface is very different from the ones that we're used to, because it is designed in a way that you can change it fully. It's designed in terms of windows, like no Windows, the operating system, but the idea of a window. You know? So you can have as much windows as you like inside a Blender window, let's say, and select which kind of work you are going to do in each window. And you can also have, if you have several monitors, one Blender here, one Blender there, then they are all together on the same program at the same time. Okay? We're going to check how to do that later. When I was talking about physical animations, this is the kind of things, for example, that you can do, no? Breaking a car, calculating the collision of different things so you can get the animation automatically. You just define some parameters on the materials, on the gravity, etc., and run the simulation. And right now, with the graphic cards, the GPUs that are very powerful and not so expensive, you can do this in a home computer, let's say. You don't need a full server computer for calculating these kind of things. There's also, well, I already talked about smoke, fire. All of this is very easy to do, and it's not very suitable for Fab Academy, but I'm just trying to showcase more or less what is inside Blender. There's a lot of projects like this that born in a university, for example. One PhD started a modeling of a smoke. So he developed a software that's open source, and someone else got that software, integrated inside Blender, and pop, you have a fire simulator. So you have an ocean simulator, a wave simulator, all kinds of simulators inside Blender, okay? When you want to do your presentation, and if you want to do a nice video of your product burning up, you can do it in Blender. This is there's also a big system around particles that can be used also to simulate liquids and the behavior of liquids. Yeah, the liquid system in Blender is very powerful. It's a little bit heavy. You need some time to calculate this stuff, but it's very, very nice. And also the rendering is, everything is do it on real time inside Blender, the calculations. Not always, depending on the kind of materials, but this kind of renders, you can get it in a good GPU on real time.
How does it compare to After Effects? Because I recently did a similar animation like that with particles on After Effects.
Okay, After Effects have, as a design, is a 2D compositor. No? So it's like a Photoshop on time, let's say. No? You can composite images on layers and move them or animate them around a long time.
Yes.
So you can do that in Blender. I will show you later how, in a node-based system. It's more similar to Nuke. Maybe if you're in that world, Nuke is one of the most powerful compositors for 2D video. After Effects is more spread because Adobe is a big company, but it's not the best in that kind of work. You can also do that in Blender, But that's different from this, because here you're calculating a 3D mesh that's built of liquid. It's not just the image that you build. You have a real object with geometry, so you can 3D print your water later if you want. It's not just the view. Okay? In After Effects, you normally do 2D particles that simulates stuff, so you can show them in a movie or in whatever. Here you really build the object. No?
Is it like the equivalent of vector base? Vector, like
Vector based, not
in 3D?
I have to explain a lot of things, but vector based is as a 2D technique, let's say, is when you are talking about bitmaps, you're talking about a map of points that only has a color and transparency property, each point. No? You put them each other after the previous one and you get an image. Vectors, you have mathematical equations that define some curves, okay? So you don't have the concept of resolution because you can render your curve every time at different sizes. Inside, all of that is 2D. You can extrapolate the same concepts to 3D. Just give one more axis. No? So inside Blender, you can do the equivalent of vectorial drawings, but in 3D, you can do that with Bezier curves. In 3D, Bezier surfaces, with etc., etc. But you can also do more or less the equivalent of a bitmap with meshes, because you have points that you can organize in space and give them properties as color and a lot more properties. Okay? I'm almost there with my propaganda of Blender. This is a particle 3D system. Normally in After Effects there are systems of particles in 2D. Here you can do a lot of things, but in 3D, I insist. No? It's based on little balls, but those balls can be anything. Can simulate water, smoke, depending on how you do the final step, let's say. That simulator only calculates the movement of a material when it hits, when it drops, when whatever. Okay? And you can give the material different elastic properties, rigidity, stiffness, etc. This is nice sometimes to do a modeling that's not so hard, because you can use some variables that will give you some randomness, some style in your... yeah, this is a little bit sadistic, but... I haven't seen this video before, sorry.
I think he was testing the model.
Okay. Well, after all that VFX and all that stuff, I already explained a little bit of modeling techniques, but also there's a technique that's called sculpting. That's very similar to sculpting clay with your hands. That maybe you know a software called ZBrush. Almost anyone has seen that kind of software where you can just like push and pull clay to build something. Blender has a really, really powerful sculpting module where you can, let's say, build 3D models, but in a more intuitive way without obviously exact measurements of the part, etc. But this is very useful. I teach it normally linked to 3D scanning, because when you 3D scan a person, for example, you will end up with a point, a cloud point, and with these tools you can fix that cloud point and work with it very easily and get very good results. Okay. There's also a technique, well, no, it's not a technique, it's a feature of Blender that will subdivide the mesh. A mesh, as I told you before, is some series of points, but it has a fixed resolution. For example, if you have a cube, you have 8 points. And you can modify whatever you like, but you still have 8 points, so you will not get a curved surface in there. It's just 8 points. If you want to convert it to a sphere, then you need more points. No? So one of the good things about this is he calculates that. So you ask for this kind of surface, and he calculates how much points do you need to get a surface like that. And you just define the level of detail you want. So if you want a very detailed surface, you ask for more points. Obviously, that will hang more your computer, depending on what you're doing. But you will get it without having to put a starting mesh with all that points. No, it will be dynamic. The creation of points will be dynamic depending on the. That allows you to do, for example, very good details on the eyes without having to have too much points on the cheek because you don't need it. Okay, so it's calculated on real time depending on what you're doing. That kind of tool, for example, if you can see, he's like pulling the nose and pushing the nose, etc. is very good when you're dealing with very big clouds of points from 3D scanning. Also, to clean 3D models, this kind of techniques works very well. Okay, well, this is a video of a guy doing hard surface, more similar to what you do in a CAD package. You can do more or less the same workflow that you do in FreeCAD or any kind of package of that of CAD modeling, with booleans, with let's say primitive meshes, joining cubes, adding spheres, doing cylinders for making holes, etc., etc. But Blender doesn't have tools like, for example, do a hole in this plate, but keep the hole always at 5 millimeters of the edge. Okay, this kind of tools doesn't exist here on a default basis, but there's a lot of scripts or add-ons that are put inside Blender by the community that allow you to do that. Okay. Also, there are, if you are more into parametric design, there are like mixed workflows where you can use OpenSCAD or FreeCAD or Solvex. There are several open source packages that you can link with Blender and do the parametric in one part, and the product of that, put it inside Blender to fix some other stuff and things like that. Okay. At the end, when you are working for 3D printing, you always end up with an STL that's a mesh. It's not parametric. So normally you have several different files in all your workflow, and each file has advantages and disadvantages. No? The Boolean tool in Blender has become very powerful, so now it's very easy to do this kind of, based on primitive object, this kind of things. You didn't have yet OpenSCAD as a class, right?
We talked about it.
Okay.
We covered many softwares last week.
Okay.
You talked about it a lot.
Because that, from my point of view, is one of the best approaches if you're really into parametric modeling. No? If you want to build a hinge, for example, that can be configured for any door, you just write a program, not model a hinge. And that program will build a hinge for you. So you can also do this inside Blender in Python. You can do a script that builds doors. And you just define the different features you want in a door and combine different features, and you get. Obviously, that's a lot of work if you just want to do one door. But if you're going to do a factory that does any kind of customized chair, then you can build a script that defines a chair, let's say, in a more conceptual way. And you just say this height, this wide, this several variables, and that will build a chair. Okay?
What was that program that you said?
Well, there are several programs to do that, but OpenSCAD is one of the. I always talk about free software, sorry. If you want proprietary software, you need another teacher, and you have a lot of them that will teach you other kind of software. My solutions will always be free and not always the easier to learn, but in my point of view, free tools offer a lot of advantages against proprietary, not always in the interface or on how to learn them. But OpenSCAD is very famous, a lot of people use it. For example, you know MakerBot, I can imagine, no? The company that does 3D printers. They started like a company that's fully open source printers and use open source software. So they built a solution for using OpenSCAD, this package, inside their Thingiverse, you know it? It's a web page where you can download models built by other people, or you can post your models for 3D printing. And they built a solution based on OpenSCAD to customize models inside Thingiverse. Okay? So for that kind of stuff, having a parametric software is very good. And when it is open source, you can do that. When it's closed source, you cannot do that unless you pay a lot of money to Autodesk or whichever. Okay. So, let me breathe a little bit. Okay. So we're going to switch to Blender. So Blender, as I said before, is an interface that has evolved a long time, but its origins are designed mostly for being efficient. Okay, so maybe some of the user interface parts will be a little bit strange at the beginning, but once you get used to it, they are very, very fast for working. The default screen of Blender when you open Blender is this. Here you have a 3D view of your model. They always put a cube inside so you don't feel empty when you open Blender. But this view is just a default view, let's say, designed by the UX guys in Blender for everyone to do 3D modeling, basic 3D modeling. I'm going to explain more or less the parts. As I said to you before, Blender is based on Windows. So as you can see, this is a timeline, okay? This is the time, and I can move a long time. But my timeline is also a window that I can do bigger or smaller. And my 3D view is also a window that I can move from one point to another. And my buttons are also a window. And here I have an outliner that's a list of objects with properties that's also a window. And each of those windows, I can change them from being a 3D window to be another type of window. There are several types of windows inside Blender to do different parts of the code. For example, if I do Python console, then I have a Python console instead of my 3D view. That's very strange for a 3D program, but you can start programming Python inside Blender. No? Or if I want to write my thoughts about my model, then I can start a 3D file, sorry, a text file, and I can start writing a list of the parts of my model inside Blender, and he will save all of these, let's say, different files, because you have a text file, a Python script, a model, an image, inside only one file. That's a blend file that has everything inside. Okay, so it's kind of an operating system at the end, because you have a word processor, a 3D modeler, a painter, a lot of things inside. Since at the beginning it's very difficult to find out what do you want, they already put some screens, like a default for each kind of task, or the normal tasks, let's say, inside Blender. So in the top, there's a bar, that's another window, that if you pull down, you reveal the commands. For example, if I move my cube, here will appear the instruction in terms of code that I did over my cube. No? Move it on that axis that much. I can copy all that and use it inside my Python scripts, for example. I can do several things, look how it was done in terms of code, and use that code. And this bar is not only the console, let's say, but it also has the main menu. the file menu where you can open files, save files, the render menu, a window menu. I will show you later the functions of every window, and a help menu. But these two here are very important. The first one will show you different arrangements of windows that came by default. And you can also build your own arrangements. You can customize it and say, I want this kind of window with 8 windows, let's say, for doing a 3D scanning. So since it is very powerful for doing that, I will save it as 3D scanning. So I'm going to show you more or less what comes with Blender as a default. The 3D full view is just that. Is when you are like a guy that needs zero distraction to do your 3D modeling. With this screen, you just have your cube or whatever you're working on. Then the animation screen is designed so you can control your object in this point, have a camera, a little camera view on the top, a list of your objects, a property window, I will explain those later, and some animation tools here for moving your animation a long time, for changing the, for example, if I want to animate my cube, I just say my cube will do this, okay? He's moving. And here in this window, I can see the curve of the movement as a vector curve. And I can adjust it so my movement behaves differently, okay? And in this one, I have my keyframes. If anyone is used to doing video editing or whatever, it's more or less the same concept. So it's very similar to After Effects in this matter. But instead of a 2D view, you have a 3D view here, okay? Then you have a compositing. Compositing is the same as After Effects, as Nuke, etc. So you can, Blender is a node-based compositing system. It's very similar to Nuke in that term, in that matter. You already have Antimony class? No.
No, we talked about it.
Okay. Antimony has an interface similar to this, but Blender interface is a lot more complex and more completa. How do you say that? More complete? Okay. Well, it has more features that way. You can also program your own nodes in Python and use them inside your flow. You can use nodes for modifying or creating textures, materials, for modifying the image that you get from Blender, the render, doing some effects over the image. For example, if I do a render here, I will have the image of my cube with the default lights, and here is the image. And if I want to modify, make, for example, a blur, I just get a filter here that's called blur, and I put it inside. And since the output of my render goes through this line to the node that's modifying the output, and at the end, this is what will be saved. Okay, so you can make like a flow with nodes that modifies things, divides. I just want to do a blur on the red channel. So I get a node that splits my red, my green, and my blue, and modify the red channel and join them later together. Okay, it's a very powerful concept when you work like programming things. You can also use nodes for building geometry. So that's very, very powerful. Okay? The node window is, well, any window you can convert it to a node window, but the compositing node window, it is, you can use it here in this menu. You can select compositing, and he will show you a default arrangement, let's say, for doing compositing. In the first menu, where it's where normally it says 3D view, I think, or something like that. Yeah, you can select compositing there, and you will get this window. I was just putting an output so you can see how it works. I can put a viewer here, so if I connect the output of my blur node to the viewer, I will see my render down here. Oh, sorry. And if I do blur in X, then you see my cube blurring, okay? So in this way you can compose all the effects or modifications you want to do to your source. Your source can be a 2D bitmap, like in this case, or geometry, or vectors, or different things, okay? In some way, this is also parametric working over data, because at the end you have an input data, some nodes that modify the data, and some outputs, okay? Then the default view is the one that we already see. Game logic, we are not going to touch game today. Later we're going to have a class of connecting sensors that I said before. We're going to use this screen. Here you can, with other kind of nodes, you can connect the logic. So if you have this input in this sensor, then you translate the cube in that axis, and etc., etc. You connect inputs and outputs, but in terms of, let's say, game logic. You can also use some kind of AI, so the game will react to some external inputs. Okay. Motion tracking. I will not go very deep into this, but here you can load footage, video footage. You can track the image, for example, track the corners of every table. So you can later just put a plane there, and the plane will move like it was inside the table. You can just put a cube, and the cube will remain over the table independently of the movement of the camera. Okay, that's very good to do simulations and special effects and stuff like that. Then we have another window that's for scripting, where you have the console on the top, Python console here, where you can input commands directly via code, a 3D view so you can see the results, a text window here, where you can write more complex scripts and save them as part of your file. So for example, you can write a script that you put some horns in a cow. And then you write a script that flexes those horns depending on the size of the cow, let's say, whatever. No? So you can just model a cow and then run your script, and it will do that. No? So you can build scripts to whatever you like. You can put always 10 objects and do a script that organize those objects in a random way. No? And then you just run the script and you apply the modifications to the object. No? That's good because you can make like a toolbox of scripts once you get used to that workflow. And you can, for fabrication, for example, just sketch something and run a script that will do all the tedious work of aligning or stuff like that. No? For example, a script that can put your different pieces in a full sheet of plywood organized, and maximize minimize the surface you're using for putting all your pieces. No? Stuff like that you can do here. UV editing. UV mapping is like the part of the studios that do 3D animation that do the drawings and map those drawings on top of 3D models. Okay, when you see a game or an animated movie, you always see characters or things that has the feeling of, if you want to build, for example, a house made of bricks, you don't model each brick. You do a big cube and you map an image of bricks on top of that cube. Okay? So if you build a face sculpting like the one we saw in the video before, and you want to put some texture to the skin, you map it. You get a photograph of real skin and you map it on top of the model. Okay? Here is where you unwrap your models so they are flat, and then map those positions in your model to the positions in the texture. Okay? And at the end, we have a video editor very similar for example, Final Cut or Adobe Premiere or that kind of stuff. I just want to mention one thing about this. It's very cool that you can connect all these models together. So you can have let's say a video, for example, as an input. Track that video in the same file. Put some cars and that crash in the scene, let's say. Have the render of the cars in the compositing. You can put the cars on top of the video, and here at the end you can make the edition of the movie and put the scene where it goes. No? All of that is connected in a way that if you move some thing in the tire of the car model and you do render, all the process will get done again, and the final product will be ready again with a little modification in any part of all the process. Normally, if you do that in several software packages, you have to do the modification in this, export, import again, do it, okay? So here, that flow is very powerful in terms of productivity, okay? Obviously, all of this is thinking more in making a movie, making stuff like that. But we're going to see later how you can use these kind of tools adapted in some way for doing fabrication or doing other kind of projects. Okay? Until here, anyone has any question? I was saying at the beginning that I don't want to speak too much, but no one asked me anything. No? It's too much information for one day? No.
It's a lot of stuff.
Yeah. Well,
I just feel like we've seen so many software and we haven't had the chance to actually get into any of them. And so it's fantastic. It's phenomenal what's available there, I can tell.
I think, just for answering him, I think that right now you're in the stage of seeing all the available things, all the available stuff, and once you get into building something or developing something, you will have a full view of what you have available. Then you can choose with better idea of what you're choosing. I think in that part, my intention in this class is give you more like an idea of what you can do. How you can do it, we will see it later if you choose to use this kind of software, okay, on the practice term. But right now you can have an idea of what you can do. You're saying?
Yeah, I have 3 questions, please.
One by one, please.
The first is, you mentioned the CAD version of
Yeah.
Can you tell a little bit more about that?
Yeah. I can show you. It's a project that's starting. It's a work in progress. It's called, I think, it's Mechanical Blender. Okay. In this page, you can go more into deep of what is this. But the thing in this kind of fork is more focused on having real control, mostly on the dimensions and stuff like that. Blender, since it is designed more for artists, doesn't put that much attention on having full control over every dimension, every part of it. If you do let's say, how do you call when you round a corner? A fillet. In Blender, you don't have the same kind of control that you have in other CAD package. So this project is built with the idea to develop more those kind of tools. The snap tools, for example, where you can select any object and align it in any possible way with another object. Okay, Blender has a very powerful snap tool, but it's not designed as a CAD tool. So they are like turning the coin so it will fit a little bit more in a workflow for engineers, let's say. Okay? I don't know if I answered your question. Yeah?
I'll try it out. But then you mentioned, can you use the node editor in order to do the actual...
Can you speak a little louder? Sorry, I'm a bit of that.
Yeah, can you use the node editor in Blender to model an actual geometry? So there is not node editor that you showed.
The node editor for building geometry?
Yes.
Yeah. Not as a default in Blender, but there is a community built project for doing geometry modeling based on nodes. that's growing so much in the last year, let's say, that I'm sure that in the next versions of Blender will be included as a default. And since it is open source and free to install, with a couple of clicks, you will have it as a default part of it. Yeah. I am not very experienced in that matter. I haven't used it very well in my workflow because it's very new, but it's very powerful. I have seen some works or people working with it, and it's very powerful.
Do you know the name of it?
Right now, no, but I can give it to you later. Yeah.
Okay. Then you mentioned also OpenSCAD. So
yeah.
How does it relate to Blender?
Well, Blender and OpenSCAD are not directly related, but I mention it and I talk about that because of the fact that you can model writing code. Okay, the primary concept of OpenSCAD is like the CAD package for programmers. Okay, so you define a circle, and then you can use that circle in different points of your code. You can do recursion and do several circles with some lines of code and a loop, etc. And the same concept you can use inside Blender without a problem inside the Python console. Okay, it's a little bit more harsh because the names of how to connect the objects with the Python are a little bit more complex, since at the beginning they weren't designed for user interaction, but you can use it the same. And there is a project that is integrating exactly the same way of using OpenSCAD inside the Blender console. So more or less what I was trying to say is that kind of flow for modeling is usable in both packages. Okay?
And okay, I missed the very beginning of the lecture. Could you tell more about your workflow?
My workflow. Okay, right now I don't do any Blender work in my day-by-day work because I'm doing electronics and, well, sometimes I model some stuff, but I worked a lot of years with Blender mostly on doing effects for movies. And my original formation was like an industrial designer, so I started modeling CAD stuff inside Blender. But then I started working in the rest of Blender. Most of the work I did in Blender related to what you are interested, or what I think you are interested here in the Fab Academy, is more related to 3D printing. Okay, I can show you in a moment the printer that I put in the beginning. So it's an example of an application of Blender in this kind of work. Blender has some tools specifically designed for 3D printing, and it's growing in that area a lot. And my workflow in that matter has to do with processing STL files, because right now the community that's creating models is very powerful in the world and is growing very fast. And the STL format is very limited in a way that's just a mesh. You don't have any parametric information. You cannot modify it very well because it is meshed with triangles and sometimes it's really messed up. And Blender is very good for cleaning those objects and preparing them again for modifications and reprint after that. So like a place where you can gather different models from the community and put them together as a thing that you can reuse is most of the work that I do today. I will show you almost there. Give me 5 minutes. I'm just answering questions. And this is a 3D printer. Blender has a layer system that's very cool for doing things like this, because you can put the objects in different layers, like any package, but you can flow between layers very easily, you know? And you can just turn on and off the different layers very easily. So you can put your, let's say these are aluminum off-the-shelf parts in one layer, so I just have to define the dimensions of it. Then the parts of the printer that are 3D printed and custom modeled are on the next layer, okay? Then obviously for doing the holes and stuff in all these parts, I have to do some booleans so I can move the holes and stuff. So in the layer next to it, I have all the parts that are building inside, in fact, that part. Okay, so that kind of tools are very powerful in terms of efficiency. They are like fast. Here I have the mechanical part of the ropes that move that all the printer, and it's also cool that I have here all my nodes, my to-do list, the boom parts list of the printer, all my calculations and stuff. I start doing my text files with everything in it. No? What else? Well, these are the aluminum milled parts. This is the electronics, so you have the motors, the cables, the electronics stuff, etc. in one layer, and you can just turn off and on the other layers, so you can see how that will fit in. For example, these cables go inside this part, no? So if you see this part, you see the cut where the cables go, and when you see the other layer on top of it, you can. What else? Well, of course, you can do very nice renders of your work. One other thing is the rigging thing I was talking before. These arrows here that I selected now are a rig for the printer. This printer is based on a system called Core XY that you have to move two motors to move the X and Y axis, but when you move it in the same direction, you move X, and when you move it against each other, you move Y. That's built with this strange path of a rope, but the cool thing is you can put all that inside your design in Blender, and let me turn everything on, and rig it. So if I move X-axis, all the parts that are linked to the X-axis part will move together. In fact, if you see, even the flexible parts bend itself. Okay? So you can see how the printer will behave if you move it in one axis or in the other axis. Okay? All of that is built with a rigging system designed to build characters for a movie. But those are the same principles. You want to link different parts, you want to constrain the movement to one direction, to one axis, etc., etc.
Yeah. Say background is industrial design as far as how accurate the program is.
It's very accurate. I use it a lot for doing CNC and 3D prints. In the next class that I will do with you in Blender, where we'll do a more practical thing, I will show you, but you can use Blender only with text input. So you can say, move this object exactly 1.001 to the right. You can snap things. So, in fact, in my opinion, it doesn't lack of anything that you have in AutoCAD or in any CAD program. But that's a long discussion, and if you have engineers on front, it's a complicated discussion. So normally I say, okay, Blender is not designed for that. But in my opinion, you can do exactly the same, and more if you have like an idea of working in these things, less as an engineer and more as an open way of thinking. Okay, that's maybe what we're trying to teach here in Fab Academy.
So as far as building pieces and tools and things,
you're covered. Yeah. It's the same as saying you cannot do circuit design in Inkscape. You can do it without a problem. Okay, it's just a matter of scales. And since the units are an abstract concept, you can use a kilometer or a millimeter, so your resolution is endless. So in my opinion, you can use it without a problem. Maybe if you're an engineer in Nissan, you cannot design motors with the same accuracy that you will do in Catia, no? or whatever other package. But if you are someone building digital fabrication stuff like the one you're going to build here, it's more than enough. Okay?
Even so for product design.
Yeah, it is used for all around the world. For a lot of industrial designers use this. Also because it is very well linked to the part of getting good images of your product. When you do industrial design, it's not just how you're going to produce the part, but how the part's going to look. You know, so those both worlds have to mix. And in my opinion, here you have a well balance between the two. Because normally engineers model in an engineering package and then export the mesh and in 3D Max or whatever, they start doing some fancy images. No? Here you can do all together. And that's, from my point of view, very efficient. No? Any other question? Yeah, very bored? Sorry?
Not bored.
No? Yeah, it's one of the problems with Blender. Since I'm not doing a long course and I cannot go piece by piece and step by step, I had to bombard you with a lot of information. And when you're interested, there's a lot of resources to continue learning.
Okay, so basically it was a free software. They opened it up, people start keep some pretty cool stuff in there according to what they were interested in. So it does all sorts of stuff. That's how I get it.
Yeah. And Blender, if you go to blender.org, there's obviously the software you can download, but there's also a manual that's really well documented of all the parts of Blender. And if you go to a page that I put here in my the things that I want to show you, but I forgot, blendernation.com. It's like a blog from Blender users that will show you any kind of things you can find around Blender. There's also a community called blenderartists.org, I think. That's a forum that I read and wrote in that forum since a long time ago, and everyone is very helpful. Since it's a community and not a company, everyone is trying to push Blender to their friends and showing that they can do it and help you. And even I have seen in the forums like I have to do this, but Blender cannot do that. And one day after that, a guy says, "Well, here's a script that can do that for you. I wrote it last night." So it's a very nice community, the Blender one, and it can help you a lot. Sorry.
I have a more practical question. Are you around the Fat Labs? What days and how many hours? And can we bother you?
Yeah. I'm here all days a week, all day. Normally I'm in the first floor right now. Later we're gonna see us more. You're starting Fab Academy. When you're into the projects, I will help you a lot more in electronics than in Blender and stuff like that. Maybe that's where we are gonna relate more. But yeah, I will be around and helping you every day.
Could you repeat your name?
Victor. Okay. I don't know. Something else you want to talk about?
I'm more used to it like Rhino.
Yeah.
Like, what do you think is like better?
Depends a lot on what do you want to achieve. You know, Rhino is a very good software, and I think for most of the CAD stuff, it's better than Blender for doing that kind of work. Okay. Obviously, I have to put on top of that the free software and open source thing over it. No? Here, for example, we always have problems with people that use Rhino with the license. You just have file license for the lab, and you cannot use it here, you can use it there, and you cannot develop that because... So in the lab, we try to push more the idea of sharing knowledge and not putting boundaries to what you can do. And in that matter, what I can say is right now, maybe Rhino is more powerful in that tasks, but if you wait 3 years and Rhino still is closed, Blender will surpass Rhino. The last 5 years, I have seen Blender from here compared to 3D Max to almost the same point. So you have to, if you're choosing which software you want to learn in a midterm, like a midterm solution, you have to keep all of this in mind.
But if it already know Rhino, it's not like that.
No. If you know Rhino, you can do your stuff in Rhino. Of course, you don't need to learn Blender. Well, obviously, depending on what you want to do, but for most of the things you're doing here, you can get out with Rhino very good. And I'm sure there's people that will tell you that you can do it better in Rhino than in Blender, and the Blender fan guys like me will say, no, I can do it better in Blender. Okay, so it's more like that kind of discussion. You are going to ask something.
I have a similar question because I started a Rhino tutorial.
Yeah.
And I was wondering what should I choose.
I'm not a Rhino expert, but again, more or less, my answer will be the same. One experience for me is I started learning like in the 90s, 3D modeling. And I started with 3D Studio 4, I told you before. That's from Autodesk, one of the first packages from Autodesk. It's the one that later was 3D Studio Max, from the version 3 to I don't know which version they are on. And I invest a lot of time learning it and using it, but when I started doing professional work in the cinema world, I cannot use 3D Max if I don't pay $10,000 a year, and I don't have that amount of money because we were like 3 friends with a little studio, and so those kind of things are very complex when you're a student, because as a student they give you free license and stuff, but you have to think in a long term, where do you invest your time, and how it will behave 5 years from now or 10 years from now, that software. Okay.
No, the feeling I got from seeing what you can do with Blender is that you can do way more things than in Rhino.
Yeah, it's like a very broad package. You can do things in many areas. Rhino is more focused on one thing, no? And that thing, Rhino is very good doing that thing. Okay. Any other question? Comments? Oh. Okay. So I think we can leave it there. You will have another CAD package the next 2 hours. So start digesting this fast so you can receive the next.
What's your next software package?
Rhino, I think. No, Inge is going to teach you Rhino.
Thanks a lot.
Oh, you're welcome.
Pretty big.
If anyone starts using it and has any doubts, you're welcome to ask.
I'm working with Fusion. I like to work with conventional software as well for CAD stuff. Looked at FreeCAD. It's a little it's kind of annoying because this rotation changes.
But you can change that very easily. I can help you change that in FreeCAD.
Because FreeCAD is still better for CAD stuff than Blender. Maybe it's worth it.
FreeCAD is a very good package, but it is still not that mature as Blender. Okay, it's a project that started not that much ago,
yeah.
And it's really focused on CAD and being like a replacement for Rhino or whatever, but it's not as mature as this software. Okay. Yeah, you have to balance and decide. Okay. So we'll shut down the broadcast.